Hi everyone. So now you can talk about area of the sector of a circle. So it's the last section of this chapter. It's a bit long, okay, longer than the normal one. Okay, area of a sector of a circle. So if you have this thing, this one is called a sector, okay, then area of sector is half r squared theta. R is this radius, okay, and theta, it must be in radian, okay, theta must be in radian. Okay, this one is in radian. Okay, let's look at some examples. So you have this one over here, then A is half r squared theta, so answer is 1.2 cm squared. Then you have this one again, so something like the same, but here is still in radian, so we don't have to do any conversion. So A is half r squared theta, so it's going to be 12 cm squared. Last one, oh, it's a circle. So theta is 2 pi. Pi means what? 180, so 2 pi means 360. So this one, half r squared theta, so it will give you 25 pi cm squared. What's your normal formula for circle, area of a circle? It is pi r squared. Can you verify whether they are the same? Pi times 5 squared, 25. So 25 pi, same. So this is a more general formula. Okay, so area of a sector of a circle. The sector can be an entire circle as well. Okay, so just remember the area of a sector formula is half r squared theta. Okay, good. Right. Next, given that OA to OC, OA to AC is 4 to 5, BD is 10 cm. Find the area of the shaded region, area of this region. So if we see this, then we know what to do already, because we have two sectors here, a big sector and a small sector. We will take the big sector minus the small sector. Okay, in order to do that, we have to know what's the distance for OB or OA. Okay, so they are the same. So BD is 10, so AC is also 10. Okay, because it's a sector. Okay, so what we need to do is to make use of this information, change it to something useful in division. Okay, then what we have is what? We have OA or we have AC. We have AC because AC is equal to BD is equal to 10. So 10 is here. So you multiply over. So it's 20 over 3 cm. Again, I don't truncate. I try to use fraction. So I have this. Okay, so that is 20 over 3 cm. Okay, next. OC. The whole thing here will be this thing plus 10. Okay, this thing plus 10 is 50 over 3 cm. 50 over 3 cm should be labeled that. Okay, that is 50 over 3 cm. Okay, now, then I have these two radius. I'll be able to find the area for both sector. Okay, for area OAB, for the sector OAB, I'm using half r squared. The r is 20 over 3. Okay, r squared theta. Theta doesn't change. Theta is 0.8. So it is 709 cm squared. Okay, area of OCD. So OCD, then my the length here, the radius is 50 over 3 cm. We found it in the previous slide. So we get this one. Then the answer is 109 cm squared. So what we do, we take the bigger one minus smaller one. So area of OCD minus area of OAB. Answer will be this thing minus this thing, 93, 1 over 3 cm squared. Okay, that's our answer. Okay, not really difficult. It's just to remember one formula. That's the area formula for sector. Okay, great. So that's 93.3333. So normally I do it in the last step to truncate the error. Okay, all right. Let's look at the next one. Okay, major and minor sector. Last time we talked about what? Major arc, minor arc. Now it's major and minor sector. Okay, so now which one do you think is a sector? This is a sector and this is a minor arc. So this one is called the minor sector, smaller one. Okay, and this one bigger sector. whenever you talk about major and minor, it's all talking about a circle, and you have a small part and a big part. Okay, so this one is a major sector. Okay, no problem with this. This one is called minor arc. This is called major arc. Okay, area of major sector, area of this thing, what do you think? Is equal to half r square theta, is equal to half of r square is 3. No problem. I mean 3 square. Okay, then what is the theta? This is in radian, this is 1 radian. This whole thing will be 2 pi radian. So that's 2 pi minus 1 radian, half r square theta. So you get the answer. Now 2 pi minus 1, and hence you get this one in terms of radian. Okay, so no problem. Yes, great. Okay, so now another term called segment here. Okay, so just now what we did was sector. Minor sector is this whole piece. Major sector is this whole piece. Okay, how about segment? You do this thing, okay, you do this thing, then this thing is called the minor segment, and the remaining one is called the major segment. Okay, this one is like 2 points that is on the circle itself. You join them, then the smaller part is called the minor segment, the bigger part is called the major segment. Later we will need to use something about this one. Okay, we will talk about this one later also. Okay, so area of a triangle, preview of chapter 10. So we need to use one formula in chapter 10. So we kind of like need to cross check both of them. Okay, so we need to cross the chapters to do this. Okay, so you have this one. Okay, how do we find the area of the triangle here? We are not told about the height, so we can't use the half base times height is the area. Okay, so now we can't. So what do we do? So area of the triangle ABC is half A times B sine theta. So how does it go? You see, you have a theta here, then you know this side, and you know this side, and the angle. Means the included angle. This is called the included angle. Means that you know the two sides and the angle in between. Then you can find the area. The area is given by half the two sides multiplied together, then sine of the middle one, sine of the angle. Okay, so that's an easy formula. So remember it now. Later you're going to use it again. Okay, but now you're going to use this formula to solve problem in this chapter. All right. Area of triangle. So this one we try to figure out the area of this. Okay, a few examples here. So you can try it yourself. You see here, this is in terms of degree, in terms of radian. Then this one in terms of, don't know, it's your choice. Okay, first one, half included, right? So I take 5 times 7 times sine of the middle angle. So now it's degree here. So make sure you are using D. Okay, then answer will be 35 square root 3 over 4 cm squared. Okay, right. Next one here is in radian. So make sure you use R here. Okay, then it's 0.5 is equal to 28.6479. You can use radian and directly use this formula sine of 0.5 if you convert it to radian. Okay, if not, then you convert it back to degree, then you solve it. Okay, for this case I convert it to degree and solve it. So half 6 times 7 sine 28.6479. Okay, answer will be 10.0679 cm squared. Last one, it's a right triangle. Do you know the formula for this? It's half base times height. That's my answer. Let's think about this one. In terms of this formula over here, what do you get? Half this side times this side, then sine of 90. Right triangle, right? Sine of 90. What sine of 90? This one gives you 1. So essentially, you only have this. Half 5 times 12. Which means that this formula is actually a more general formula than the one that you used to have. The base times height divided by 2. It's the same. Okay, so you got this one, which is base times height, which is 30 cm squared. Okay, great. Alright, so this one is base times height, same thing. Okay, find the area of the segment. Find the area of the segment. Okay, segment. You know what segment? Segment is this one, right? Sector is the whole thing, right? Okay, of this segment. All right, how do we do that? We know how to find what in this chapter? We know how to find sector. Sector formula is half r squared theta. So we can find this whole area, correct? Can we find this one? Yes, we do sector minus triangle. Can we find the area of this triangle? Yes, because we have side included angle. So we use half 3 times 3 times sine 1.2 radian. Then we get our answers. Okay. So if you can, you try to implement what I said. Okay. If you can't, then you follow what I do. Alright, let's do it. Area of minor segment is area of a sector minus area of a triangle. So you know what segment? Segment is this one. Okay. You can imagine this as a big circle. Okay. That should be bigger. Okay. So then I draw a line here. So this is called the major segment. This is called the minor segment. Okay. So minus area of the triangle. Okay, let's do it. Area of the sector is given by half, then r square, then times the angle in radian, half r square theta. Okay, that's the thing that you are quite familiar already. Answer is 5.4 cm square. Okay, next I need to find the area of this triangle. So for triangle OAB, I do half OA OB sine theta. I just do a revision by writing this one for you. You see, these two I have an included angle. Okay, I get this. Half 3 sine 1.2. 1.2 is radian. Make sure your mode is R. Make sure your mode is R. And do sine 1.2. If your mode is D, you get a complete different answer. And your answer is completely wrong. It's wrong by a lot. Okay, so you get answer 4.1942 cm square. So you see, this one is a smaller one. With this one is a bigger one. So what do? We take the area of minor segment minus area of this one is equal to area of sector minus area of triangle. So easy, minus, get down. Okay, 1.2058 cm square. Okay, no problem? Great. Alright, next one. So BCD is a sector of a circle and OABC form a semicircle. OACB form a semicircle. Find the perimeter of the shaded region, which is this. Then the area of a shaded region, this. Okay, so now let's not solve this problem first. Let's observe what is in here and see what we can do. Okay, you see, the information given here is one thing only, this one. Okay, we need to figure out one by one what are the things that is here. Okay, first, do you realize that this one should be the same as this one? Why? Because this is the center point. This one is a radius and this one is a radius. Okay, so first of all, you have this one is equal to this one and this one is a right triangle. Okay, so OB, OC are radius of a semicircle. So they should be the same length. Meaning that I know this side, I know this side. It's 20 cm. Okay, you can follow? Yes. Okay, next. What do you see? Do you see angle OCB is angle OBC is 45? You see, this is 90 and they have the same length. Means that this angle and this angle, they must be the same. Okay, so they must be the same. It's 45 degrees. So 45 here, 45 here, I don't write already. Okay, leave it later. Then BD is equal to BC. Do you see that? BD is equal to BC because this one is a sector. Okay, sector. So this side must be the same as this one. Okay, that's a R, right? Okay, that's a R here, and that's a R here. That R is not related to this R. Okay, not related to this R. That R is another circle formed here. Okay, another circle formed here. Okay, so that's another sector. So this distance and this distance will be the same. Since they will be the same, do you know how to find this one here? Do you know how to find that? That one should be equals to square root 20 square plus 20 square. Why? Because Pythagoras theorem tells you that this one is the hypotenuse side. Okay, a square plus b square is equal to c square. Okay, that's why that side is square root of 20 square plus 20 square. So you get 20 square root 2 cm. So we can write that 20 square root 2 cm. Okay, last one. BCD forms a sector. This one is what you have done. So you know this side and this side is the same. So this is 20 square root 2. This one must be 20 square root 2 as well. Okay, so now you basically know everything here already roughly. I mean, at least the things that you need to solve, you can solve it now already. Okay, so let's move on to the next one. So I put all the things here already properly, so you'll be able to solve comfortably. Okay, so if you can, try to solve this because I've told you all the information already. Yeah, if you can't, then we'll do it. Okay, pause the video. Alright, now for arc CD, okay, this arc. How do you find this arc? We use this whole sector. Okay, then we know the length here is 20 square root 2. So theta is 45. 45 is the thing that you found because same length. Same length, then you have the same angle. Okay, 45 degree. So change to radian because you are going to use the formula r theta. So you change to radian is 0.7854 radian. So r is 20 square root 2 cm. So L, you just multiply them together, you get 22.2145. Okay, so that is this side. Okay, I want to find the parameter. I find this side, I find this side, I find this side, and I'm done. So this one partly done. OC, you know OC is the same as OB. They are 20. So we found that in the previous slide already. Next, OD. OD is here. Okay, you know this one is 20 square root 2. You know this one is 20 square root 2. So this one will be 20 square root 2 minus 20. Okay, so it will be 20 square root 2 minus 20, which is 8.843. What we do, add the 3, and we are done. Parameter of the shaded region is dot dot dot, add them up. This one. Okay, so I get the total for 50.4988 cm squared. Wait, cm. Okay. Okay, great. No problem. If no problem, I move on to the next one. We want to find the area of the shaded region. So you see, finding area, what we have in our toolbox, we can find sector. The whole sector we will be able to find. So we find the sector and minus the right triangle. Then we are done. Okay, easy. Now, area of BCD. BCD means the sector BCD. Okay, half r square. R we use this one, right? This one is 20 square root 2. This is also 20 square root 2. So half r square theta. Theta, this is from the previous slide. Okay, this one is from a previous slide. Okay, we change it. Okay, answer will be 314.16 cm squared. Then area of a triangle. Even kindergarten can solve. So this one half base times height. Okay, 20 times 20. So this one no argument. 200 cm squared. So I want to find the area of the shaded region. Take this one minus this one. Also kindergarten can solve. So answer is 114.16 cm squared. Okay, so I guess you are okay with this chapter already. You need more exercise for this one, okay, and do a little bit of past year paper in order to get used to the pattern being examined in the exam. Okay, so I'll see you next time. Bye.